A viewer asked, what would happen if the moon were cut in half, like in Assassination Classroom? For those unfamiliar, Assassination Classroom is a Japanese sci-fi school-themed action comedy that hit theaters in the year 2015. The movie opens with what can only be described as a shocking scene. The moon, Earth's only natural satellite, has mysteriously lost a significant portion of its mass, specifically around 70%, turning it into a literal crescent shape. The culprit? Koro-sensei, a mutated creature with tentacles. Yep, the Japanese really do seem to have a thing for tentacles. After destroying the moon, Koro-sensei threatens to obliterate the Earth by the time the school year ends. Until then, he becomes the homeroom teacher of Class 3E, a group made up of the school's most underperforming students. To prevent the end of the world, the students are trained as assassins with one ultimate mission: kill their teacher before graduation day. And that's basically the premise of the film. Now, back to the question from the audience. As of now, humanity has no known technology or method capable of shaping the moon like in Assassination Classroom. We can't even chip a piece off the moon with our current nuclear arsenal, let alone blow away 70% of its mass. Doing so would, in fact, be an incredibly self-destructive idea. Any explosion powerful enough to vaporize that much of the moon would also hurl thousands of debris fragments, some several meters, or even kilometers wide, directly toward Earth. The end result can be summed up in 4 simple words. Say your final goodbye. Even if there were a way to carve the moon into a crescent shape, such a structure wouldn't last more than a few minutes. The reason is something we've talked about many times: gravity. If you had a childhood filled with Dragon Ball Z, you might remember the famous quote, "Where there is life, there is justice." Well, in the universe, we say, where there is mass and energy, there is gravity. Gravity is a fundamental force. It's weak, extremely weak, in fact. For example, the gravitational attraction between you weighing around 62 kilograms and your crush weighing 48 kilograms, when floating 1 meter apart in outer space, is only about 0.0000002 kilograms. That's just 0.02 milligrams. To put things into perspective, Earth's gravitational pull, despite weighing about 5.972 sextillion tons, affects you at the surface in such a way that it simply shows your body weight on a scale. The more you play around with Newton's law of universal gravitation, the more you'll realize when objects are small or far apart, their gravitational pull is negligible. But when the objects are massive and close together like the Earth and the Moon, gravity becomes anything but weak. The gravitational force between Earth and the Moon, according to calculations, reaches about 20.2 million trillion tons. Similarly, the gravitational attraction between Earth and the Sun reaches around 3.6 sextillion tons. Back to the Moon losing 70% of its mass would be catastrophic, sure. But it does not mean the remaining moon could just float in the shape of a star, a crescent, or any other whimsical structure. Don't believe it? Let's do a little math. Assuming the moon's material has a consistent density throughout, which in reality it doesn't, cores are usually denser, then even 30% of the moon's mass still contains around 22 sextillion tons of material. Now take a look at these celestial bodies. 704 Interamnia, 12 Hygeia, 2 Pallas, 4 Vesta, and 1 Ceres. These are the 5 largest asteroids in the asteroid belt between Mars and Jupiter. Their diameters, from smallest to largest, are approximately 332 kilometers, 433 kilometers, 511 kilometers, 525 kilometers, and 939 kilometers respectively. All 5 of these asteroids are massive enough for gravity to mold them into spherical or near-spherical shapes. But even when combined, their total mass, according to estimates based on data from Wikipedia, is still only about 1/14 of the mass of 1/3 of the Moon. That alone tells us this: even with only 1/3 of its mass remaining, the Moon would still be far too heavy to maintain a crescent shape or any shape that isn't spherical or close to it. So, You mean the moon would try to return to a round shape? Not quite. It's not that the moon tries anything. It's that gravity forces it to return to a sphere by breaking apart the unstable crescent structure and pulling all remaining matter inward toward the center of mass, which would now become the core of the new version of the moon, Moon 2.0. The good news? Humanity would be able to witness this once-in-a-lifetime astronomical event with the naked eye. The not-so-good news? The collapse of the crescent moon, especially the fracture points at the tips of the crescent, would accidentally release millions of debris fragments of various sizes. Most of them would be pulled back in by the moon's gravity. But some wouldn't. Some would be flung toward Earth, causing, well, expansion events. There would be casualties, earthquakes, tsunamis, wildfires. Entire cities could be flattened. And in the worst-case scenario, a global catastrophe threatening the survival of humanity and many other species could occur. On the slightly luckier side, if the debris were small enough, it might end up forming a planetary ring around Earth similar to Saturn's, but much smaller before eventually falling into our atmosphere and burning up in Earth's 100-kilometer-thick atmospheric shield. But wait, the original question from the viewer was, what would happen if the moon lost half its mass and somehow kept its crescent shape, just like in Assassination Classroom? Well, the most immediate effect would be visual. The moon, now having undergone the ultimate weight loss transformation, would be pulled much closer to Earth by gravity. It would look gigantic in the night sky, like a cosmic boss battle waiting to happen. Along with that, the moon's orbital period. The time it takes for the moon to complete one trip around Earth would shorten significantly. This would heavily disrupt lunar calendar systems, also known as the lunisolar or moon-based calendars, which rely on the moon's orbital cycle and appearance as seen from Earth. The concept of a full moon would quickly become an ancient term. Future generations of girls might raise an eyebrow when someone jokes that they're blooming like the full moon. They'd have no idea what that even means. Also, a non-spherical moon means total solar eclipses would be impossible, since a crescent-shaped object can't fully block out the sunday. However, partial eclipses and lunar eclipses, even total ones, could still occur. Naturally, things wouldn't stop there. With only 1/3 of its original mass, the moon's tidal influence on Earth would also plummet. That means lower tidal ranges in oceans, seas, lakes, and rivers. While this would deal a serious blow to the fishing and aquaculture industries, it might be good news for cities in low-lying regions that frequently suffer from tidal flooding. They'd dry up. Zooming out, weaker tides would have massive consequences for many marine ecosystems. Entire tidal habitats could vanish in various parts of the world. And finally, here's a fun twist. For billions of years, the moon has been gradually slowing Earth's rotation. That means it has been making our days longer, adding about 20 microseconds each year and sneakily forcing us to work more every day. At this rate, our distant descendants in the year 180 million 2021 will face 25-hour days and possibly 9-hour workdays. Terrifying, isn't it? If the moon were reduced to just 1/3 of its original mass, that 25-hour day would remain a very, very distant threat. And with that, thank you for watching, and see you next time.